saying starts at 3 and jumps to every time doesn't tell us how to calculate the 10th or 100th term, or in general an nth term. So we are going to devise a formula, a method, okay, to arrive at any general term. A term is nothing but an element in the sequence, okay, any term. It could be this term. How to find this term in the sequence? It could be any term for that matter, okay. How to find the formula? So what would be the rule for 3, 5, 7, 9, etc. be? Firstly, we can see the sequence goes up to every time. So we can guess that the rule will be something like 2 into n, where n is the term number. For example, this is the third term. The value is 7, but the term is 3, right? Third term, and this is the first term. 2 into first term is 2, right? So 2 into 2 plus 1. 2 into, this is the first term, 2 plus 1. 2 into 2 plus 1. 2 into 3 plus 1. So we have the number term, okay. Let's test it out. Here the term n is 1, okay. The term is 3. 2n equal to 2. 2 2s are 4. The value is 5 though. So here it is 7, but the test rule is 2 into n, okay, where n is going to be 1, okay. So you look at the test rule. We have created a test 2 into n, okay. So we see a pattern 3, 5, 7, but the value or test rule says the value should be here. That nearly worked out. We came somewhere near now. How much it is low by? You can see the value is less by 1. Every time we apply the test rule, it is less than 1, right? 4 means here it is 5. The term value is 5. The term is 5. The term, the nth term, the first term is 3. The second term is 5. But the formula gives us close value, right? How much it is different? So we see only it is differing by 1. So we rechange the test rule by adding 1. 2n plus 1. Then apply it here. N term is first term. The term value is 3. The first term is 3. 2n plus 1. 2 into 1 plus 1 gives 3. Okay, now we got the term matched with the formula. The second term is if you apply the formula 2n plus 1, or you can call it test rule, 2 into 2 plus 1. Okay, you see I'm substituting n with the term or element position, okay. We get the value now. So look, 3, we get it 7. So it matches the term, right? Element or the thing, number, whatever you can call it, okay. The position is represented by the term n, the symbol n, okay. Which term it is? The third term is 7. Okay, we found that the term works. Okay, the formula, the rule works for all the terms. So instead of saying starts at 3 and jumps at 2 every time, we write the rule as the rule for 3, 5, 7, 9, etc. is 2n plus 1. Okay, make a note. This is how we arrive at a formula. For example, we can calculate the 100th term very easily. What would be the 100th term? 2 into 100 plus 1, 201. Without even going through all the numbers, we can exactly say what would be the 100th term. Okay, this is good. Notation, to make it easier to write down rules, we often use this special type. Look, there is a notation in making the rules. The term or element is going to be xn. The term number is n. Which term? You look at the x and look at the term, how it is denoted here, okay. Then term number, xn is the term number, n is the term number. For example, the term number 1 is this, okay, and it is represented by 1 here, okay. The value of the term is 3. First term is 3. 100th term is 201. So 1 is the term, n is the number term. So to mention fifth term, you must just write x5. So the rule for 3, 5, 7, 9, etc. can be written as an equation like this: xn equal to 2n plus 1. Right? Now if we want to calculate the 10th term, we can write x10 equal to 2n plus 1 equal to 2 into 10 plus 1, 21. Now can you calculate what is the 50th term and the 500th term? Yes, take this as an problem and solve it. Okay, let's go on to the next one, types of sequences. There are two types of sequences: arithmetic sequence and geometric sequence. The first one is the arithmetic sequence. Here is an example we just used. 3, 5, 7, 9 was an arithmetic sequence because the difference between one term and the next term is a constant. You know what is it? It's a constant, so it doesn't change variably. Okay, it's 1, 4, 7, 10, 13. In this sequence, the difference is always 3. It's constant, right? Its rule is very simple. How to write a rule? Xn equal to 3n minus 2. Okay. In this sequence, you get another one: 3, 8, 13, 18, 23, 28, 33, 38. Here we can, the difference of 5 between each number, the difference is 5. So the rule we can write is, the position is 3, it's 5n minus 2. Like for example, first position is 5 minus 2. So substituting 1 for n, we get 3. Okay, 2, it's 10 minus 2 is 8. Likewise, we can arrive at a formula and substitute the value for the terms. So this is constant for all the terms, so it is not varying. This rule applies to all the terms constantly. If it is not a constant, what it means? See what is a geometric sequence is. In a geometric sequence, each term is found by multiplying the previous term by a fixed amount. Here, for example, the sequence 2, 4, 8, 16, 32, 64, 128, 256. This sequence has a factor of 2 between each number. Between this term and this term, okay, each number, the rule is 2 to the power n. Like for example, you got to multiply the previous number by 2. You multiply this number by 2, you get here. This number by 2 gets this number. Likewise, if it depends on the previous element or number in the sequence, it is called a geometric sequence. In the arithmetic sequence, we were constantly adding value to all the numbers. This does not depend on this number. 7 does not depend on 10, 4, right? So we are just adding it based on the position. Here, 3, 9, 27, 81. This term depends on this one. So 3 into 3 of this term gives this one. Likewise, 3 into 9 gives 27. 3 into 27 gives 81. Okay, there is a factor of 3 between each number, multiplying it, right? Its rule is, what is the rule of it? Xn equal to 3 power n. Okay. Let us take this example: 4, 2, 1, 0.5, 0.25, ... This sequence has a factor of 0.5, a half between each number. So its rule is Xn equal to 4 into 2 power minus 1. 2 power minus 1, you know, right? It has to be 1 by 2. It is the factor of 0.5 between each number. Okay.